which of the functions given below have an inverse function? And there are 4 different functions given. The first is f of x is equal to the floor of x. Second is f of x is the square root of 9 minus x squared. That's got a restricted domain from -3 to +3. Third one is a constant function, f of x equals 17 for all real x's. And finally, f of x equals x for x an element of R. Well, as you can see below, we're going to do this graphically. All 4 of these are functions, so they all pass the vertical line test. The question is, do they pass the horizontal line test? And if they do, then they have inverses. So let's start with the first one, which is f of x is equal to the floor of x for all real valued x's. As a quick review here, floor of 2.7. Basically, that gets rid of everything to the right of the decimal point. So what this indicates is that for this particular function, f of 2.7 is equal to 2. Now, if you put some tick marks on the axis, here's what you have. That particular point, namely 2.72, shows up right here. Here is 2.7. When you go up to 2, there is that point on the graph. Now, if you try a bunch of other trial points, what you're going to find out is that everything from 2 until just short of 3 is going to give you a 2. And everything from 1 to just short of 2 gives you a 1. Everything from 0 to just short of 1 gives you 0, and this pattern continues. Now, once again, the problem tells you that these are functions, so notice that every vertical line will strike this graph either 0 times or 1 time. However, if we take a horizontal line, let's say the horizontal line right here at 2, that will strike this in multiple positions, so the answer to this question is no. There is no inverse for that function. Let's go on to the second one. F of x is equal to the square root of 9 minus x squared. And that has a restricted domain from -3 to +3. So we'll put 3 tick marks here and 3 tick marks over here. Go ahead and evaluate f of -3. What do you get? You get the square root of 9 minus 9, and the square root of 9 minus 9 is going to give you 0. So the point -3, 0 is on there. How about +3? F of 3 is the square root of 9 minus 9. Square root of 0 is again 0. So you get this point here. Try the point x equals 0. In that case, you get f of 0 is the square root of 9 minus 0 squared. The square root of 9 is 3. So the point 0, 3 is also on the curve. If you plot a number of other points, you'll find that this is a semicircle, something like that. So now check out the horizontal and vertical line test. It is a function, so every line that we can draw will intersect this curve 0 or 1 times. But if we take a vertical line, let's say the vertical line right here at y equals 1, it will intersect the function right here. It'll also intersect the function right there. So the answer is no. This function does not have an inverse. Next one, f of x equals 17 for all real numbers. Well, in this particular case, if I draw 17 tick marks, there they are. I could draw the function f of x equals 17, and there it is. Notice once again, that passes the vertical line test. We know that because it's a function. But I can come up with a horizontal line, namely the one at y equals 17, and it does not intersect that 0 or 1 times. And because of that, the answer to this one is no. That function does not have an inverse. Finally, the very last one here is f of x equals x for all real numbers. And that is a line with a y-intercept of 0 and a slope of 1. So that is a 45-degree line that passes through the origin. And notice this particular function, unlike the others, will pass the vertical line test. We know that because it's a function. But it will also pass the horizontal line test. And because it passes the horizontal line test, the answer is yes, this particular one does have an inverse.